Okay. What a matrix is, by the way, guys, it allows us to organize data. That's really what it is. Organizing data. So, kind of like how I started doing on the story problem, if you guys recall, I kind of had, if we, like, we had that different type of medicine for rabbits or something like that, about the two different meal choices. If you guys remember that two feed things. So there was feed one. Ooh, that was bad. So we had two different feeds. We had feed one and feed two. And then there were different items off of that. Like there was protein, fat, and calories, let's say, something like that. And this had like 4, 10, 120. I'm just making this up. Okay, 5, 15, and 100. Okay, it just organizes the data in a specific way. But instead of having these brackets and matrices, they usually do have the brackets. Okay, they just have the brackets. And it just organizes data. That's all the matrices does. Okay. Now, when we name a matrix, or tell its dimensions, on the dimensions, we go rows by column. That's how you tell the dimensions of the matrix. So in this case, how many rows do we have? 2 rows, and we have 3 columns. Okay. Everybody? 2 rows, 3 different columns. Okay. What we can do, another item that we've seen, is let's say we have this problem right here. And then it looks like this. I can also make equations, a system of equations, into a matrix. Okay? This is called an augmented matrix. It would look like such. Notice we have 2 rows by 3 columns. Okay? If I want a specific element of a matrix, so for example, if I wanted to know what is this term or element, we call that an element, okay? That element would be, we could call this matrix A if I wanted. Right? This would be element 1, 2. Because what that means is I'm in row 1, second column. So you could name a specific element. Does that make sense, everybody? So notice this would be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2. Right with me on that? Going over some of the basic items. So we're actually going to use a matrix to go ahead and help us solve an equation. I like using matrices in an organized fashion to solve. Now, I am going to tell you, this does become a tedious process. It takes a lot of paper because sometimes you're doing multiple steps in a matrix. Okay? But it's a very simplified, if you do it work, it works every time. Very distinct on how you work. I'm having that same problem. I'm dying, I swear. Okay, let's go ahead and put this as an augmented matrix. Okay? Augmented matrix. So this would be 2, -1, 5, 1, 4, 7. Now, for me, I like to do a little dotted line here to represent that in equal sign. Okay? So that's representing 2x minus 1 equals 5. Minus 1y equals 5. Does that make sense? That's what I personally like to do. Does the book necessarily do that? No. So just be aware of that, okay? Now, when I solve this, we have two different types of methods. Okay? We have what we call row echelon form. Which is also called Gaussian form. Okay, and I'll show you what we do on that. The goal of row echelon form is to have it like such. In our case, we have a 2 by 3, right? You want it to look like this. 1, 0, A, 1, B, C. That's what row echelon form is. Now, A, B, and C just represent numbers, we just don't know what they are. Okay? But the key thing is you want ones down your diagonal and zeros to the left. So if it was a 3 by 3, here's what it would look like. So if I had 3 by 4, so it would go 1, A, B, so D, 0, 1, C, E, you get what I'm saying here. You see how I have ones down my diagonal and zeros below? Okay, this is called row echelon form. That's your full key. Now what this means, though, is notice this is our x column, y column, and z column, right? So what would z equal? F in this case, right? Then I know x plus 2z or cz equals e, and then I can substitute that in. I'll show you how to work that. Okay? Any questions? Okay? I'm going to show you both ways. So far this is just row echelon form. I'll show you what we call reduced row echelon form. Okay, so let's see, what was that matrix that I had above with the formula? 2, -1, -1, 1, 4 equals. All right. Is everybody there with me? We're going to do row echelon form or Gaussian elimination. Okay. The thing that we want to do here is I want a 1 right there. Now, just because they wrote this equation on top of this equation, doesn't it mean that I can flip this equation? Can I maneuver equations if I want it? Really, does that make a difference? It doesn't. So, here we go. So the next step, I'm just going to do a little arrow, is 1, 4, 7, 2, -1, 5. Because I got a 1 where I want to be a 1. I always want this top corner to be a 1. Does that make sense to everybody? What if neither of them were a 1? Then I would have to go ahead and if I wanted this to be a 1, how do I make it 2 be a 1? I can't just minus 1. I'm in the equation, could I? Because this is technically 2x, isn't it? So what would I have to do to make that 1x? Divide everything by 2. Does that make sense? Okay. All right, so far we're here. Okay? Now, the next thing thing I want to do, is I want to make this guy a 0. Okay? Once again, I want 1, 0, 1. Does that make sense? So you always get here, work yourself down. Then go here, work yourself down, but we don't have any more there. Does that make sense? So I'll show you the steps. If I'm in a 2 by 2 situation, I want to go 1, 2, 3, and then I'm done. I have 3 steps to get there. I want this to be a 1. I want this to be a 0. I want this to be a 1. Those are the steps that I would go. Okay? If I had a 3 by 3, I would go like this. Go step 1, step 2, step 3, step 4, step 5, step 6. Okay? I want to have it in that order. I got to go here first, then come to here, then go down, then work through here. Okay? You'll see what I mean in just a second. Does everybody understand? Kind of, maybe not really understanding yet, but I'll show you what I mean by that. So far we've got step 1 because I got a 1. Now I want this guy to be a 0. Now how do I get that to be a 0? Do I just times everything by 0? No, because then that whole bottom row would be 0, right? So that doesn't make sense. So I'm going to be doing just like we did, we're going to do a elimination. Okay? So what do I need to times row 1 by? -2, right? So if I times that by -2, I get, I get -2, -8, -14. So I'm just going to keep row 1 as he is, 1, 4, 7. But to get to here, what I did is I'm going -2 times row 1 plus row 2. Is everybody see what I did there? I multiplied row 1 by -2. I'm going to add it to row 2. Okay, so what's -2 plus 2? 0, and that's the goal. Our goal was to get a 0 there, wasn't it? Right? -8 minus 1, -9. -14 plus 5, -9. Any questions there? Okay, so far, look, I have a 1, a 0. What's our next thing we want? A 1 where the -9 is right now. Right? Does that make sense, everybody? Excuse me. Okay, so with that being said, how do you guys think I get to a 1? So I'm going to take row 2, and I'm going to divide it by -9. Okay? So I have 1, 4, 7, because I didn't do anything to him, did I? 0 divided by -9 is still 0, and that's the reason we want that to be 0 before I go to the 1, because that'll never change. Does that make sense? -9 divided by -9, 1. -9 divided by -9, 1. Okay. So this right here is called row echelon form. And that also tells us an answer. Because once again, what is this column representing here? The first column. That's representing X. What is the second column representing? Y. So I could change this back to say, oh, this is X plus 4Y equals 7, isn't it? What does the bottom row say? Y is 1. See what I'm saying? Is that basically what we just did, right? In the last thing, but it's in an organized fashion. Right? And it tells you exactly what steps you have to take. So it's very organized. And that's sometimes why I like it. It's a very procedural opportunity. Right? Okay, then how do I find X, Y, Z? Plug it back in. Right? Okay, so I'm going to go ahead and plug it back in. I get X plus 4 equals 7. So X is 3, and there I have my solution. But there's another way that I could find my solution. I'm going to stop here. This is what's called row echelon form. But I can go on to another step. There's another step called Gaussian-Jordan elimination. CAUSS organization, which is called reduced row echelon form. And what that looks like is this: 1, 0, 1, 0, dot. So what would this represent if I had to finalize matrix? We would say x equals a and y equals b, doesn't it? So, and in this case, if I had this as 2 by 2, this is the order how you do it reduced row echelon form. I go 1, 2, 3, 4. That's the steps I go. Find a 1, find a 0, find a 1, and then I find a 0. So that's the procedure that you need to go with. Okay? If I had a 3 by 3, okay? If I had a 3 by 3, I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9. What I'd have here, if it was on reduced row echelon form, for a 3 by 3, it would go 1, 0, 0, 1, 0, 1, 0, 0. That's the goal of what you want it to look like. And the reason being is dot, 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 A, B, C, then that's saying x equals A, B equals C, and x equals A, y is B, Z is C. Does that make sense? Yes, sir. Just kind of, we'll go over the steps, we'll do it quite a bit. It just comes through faster. But it's very similar to what we've done here. It's just a more distinct way of doing it. Okay? All right. So, can somebody tell me what I got to on the row echelon form? I had 1, 4, 7, is that correct? And then I had 0, 1, 1. Yes? Okay. Now, could we find our solution from here? Did we find our solution that x was 3 and y was 1? We did, didn't we? But now, instead of having this back substitute, we're going to go ahead and make that a 0. Well, that 4 is, we're going to make him a 0. Okay? Anybody have an idea of how I'm going to make him a 0? -4. Got it. That's exactly what we'll do. So, it says, toss your name. Hold on. Oh, I got it. Starts with what letter? No, I know you, Kaylee, and I know you too, but I just stuck on it all of a sudden. Tell me your first letter of your first name. Last name. Come on. Oh, what am I doing? Why? Okay, just tell it to me. That's Hippel, damn it. Yes, Jacob Hippel. I'm horrible. I love you anyway, though. Okay, so as he said, though, I'm going to take row 2, and I'm going to multiply that by -4. I'm sorry, Jacob. And I'm going to add that to row 1. Okay? So, noticing the reason why I want this 0 here, watch what happens. Because this is still 0, isn't it? And when I add 1 plus 0, doesn't he always continue to stay 1? You see why that's important to have that 0 there before I go back up? You get what I'm saying by that? Then this guy's -4, -4. So, 1 plus 0 is 1. 4 minus 4 is 0. 7 minus 4 is 3. And then I just notice where's that first column representing again? X plus 0y is 3. So x is 3. 0 x's, 1 y. Yeah. Yeah. You solve for the y, and then you come back. Now we're going to do it with a 3 by 3. Okay? And with a 3 by 3, I don't necessarily always want to do reduced row echelon form because it's 9 steps. You know what I mean? And sometimes I'm like, is that really beneficial? And sometimes it is. But we're going to go with that. Okay. Okay, you guys ready to rock? I hope it comes out nice. Good. We've done these already before. We've solved 3 by 3, haven't we? Right? So it's nothing different, but this time, once again, it's more organized thought process. That's what we're doing. More organized thought process. Okay, so first off, we're going to put this into an augmented matrix. Okay, augmented matrix. Okay, so that will be 1, -1, 3, 4. 1, 2, -2, 6. 3, -1, 5, 14. All right, ladies and gentlemen. First goal, what's our first goal? Step number 1. Top left corner, what number do we want there to be? A 1. Hey, we got it. Step 1's done. Step 2, what do we want? We want a 0 right here in, we call that A21, right? Does that make sense? We want that element to be a 0. That's our second step. Okay. So as I do so, what's an easy way to get that to be a 0? I like to always add rows. So I'm going to go negative row 1 plus row 2. And notice this is just telling me what I'm doing. This is my instructions to myself. Okay? So this is going to be -1, 1, -3, -4. Right there with me? So I have 1, -1, 3, 4. Our top row doesn't change. Okay? What is -1 plus 1? 0. 1 plus 2. 3. -3 minus 2 is -5. -4 plus 4 is, hold on, -4 plus 10, was that 10? Or was that 6? Okay, what is 10? Sorry about my handwriting. Is 6. Any questions on how I got that? Now I have him still down here. Like I said, it just takes a lot of paper and patience, right? You're gonna have patience and paper, promise you. Okay, you might fill a whole damn tree in this. So. Okay, what's our next goal we want? We've got first goal and second goal accomplished, haven't we? What's our third goal? Where that 3 is, what do I want him to be? Where this 3 is, right here. I want him to be a 0, don't I? So I'm going to take row 1 again. And what am I going to do to him? Times by -3, right? And I'm going to add that to row 3. So I get -3, 3, -9, -12. Those numbers up there are just our multiplication, right, of what I want to do. Then I start my new matrix. Okay. I have 1, -1, 3, 4, 0, 3, -5, 6. What do you guys think people do a lot of in this case? You're copying and there's a negative. They lose stuff, and that's when stuff starts to happen. Okay, so you got to be very precise as well. Precise, patient, paper. We got the triple P's right now. All right, so here we go. -3 plus 3, 0. 3 minus 1, 2. -9 plus 5. -4. -12 plus 14. 2. Any questions on how I got that new matrix? All right, so we've got 3 steps out of a guaranteed 6. I have to do a minimum of 6 steps. Okay? What's our next goal? Where that 3 is, in the second row, I want that to be a 1. But notice, how do I make things a 1? By dividing by that number, right? So if I had a 3, I'd divide by 3. But I'm not going to do that this time. Can anybody tell me why? I don't like that row. That row sucks. Because when I divide freaking -5 by 3, that's a fraction, and I don't want to play that. You guys want to play that? Look at this guy. If I divide everything by 2, would that be a nice row? So can we still switch rows at any time? Sure, it doesn't matter. Because what is this saying right now? 3y minus 5z equals 6. And this is 2y minus 4z equals 2. Does it really matter if I switch those rows? So I'm going to switch them right now. Okay, so I'm going to say switch row 2 and row 3. You guys understand why I'm doing that? Could I still get the same solution if I was going to go ahead and go backwards and still do it? Yeah, I'll get the same thing. But to make it easier on myself, I'm looking for the easiest possible. Right? So I have 1, -1, 3, 4, 0, 2, -4, 2, 0, 3, -5, 6. And that's where I stay. So now, what's our goal to make that a little bit? To be our fourth thing. I want to divide everything by 2. So I'm going to take row 2, divide by 2. Yes? Feel good? Now, am I going to say every time you're going to have nice rows? Are you going to sometimes have some fractions? Okay, but understand, if I can help it, switch it, make it a little bit nicer. All right, so I've done 4 steps now, haven't I? Remember, 1, 2, 3, 4, 5, 6. Process we're going to go through. What do we want this 3 to be? We want it to be a 0, don't we? Okay, so how am I going to make that a 0? Well, I'm going to times row 2 by -3 and add that to row 3. Now, once again, that's why it's imperative to have these as 0. Because when I multiply this by 0, notice there'll still be remaining 0. That makes sense to everybody? You feel good with that? Okay, so this would be -3, 6, -3. So -1, 3, 4, 0, 1, -2, 1. I'll have 0 plus 0 is 0. -3 plus 3 is 0. 6 minus 5 is 1. -3 plus 6 is 3. And notice, guys, our 6th step is already done for us because it just so happened when I add those 2 rows together, it became a 1. Is it always going to be that? No. Are we in row echelon form? We are. Okay? Now, you could stop right here and still solve. Because what is z? Z is 3, isn't it? Okay, because I could come back to this. That's really what I'm standing at, am I not? Okay. Any questions there? Okay, so then how would I solve for y? What would I do? Plug in the 3 for the z right there, right? So y minus negative 2 times 3 is negative 6 equals 1. Y equals 7. Then I go back up to the original equation, correct? X I don't know, but y is 7, and z is 3 times 3 is 9, equals 4. Okay? So I can stop at row echelon form, unless it tells me to continue on to go to reduced row echelon form. Right? You guys understand the difference between the two? Row echelon form is 1 down the diagonals with zeros below it, and you could have numbers above. But reduced row echelon form has 1s down the diagonal and zeros everywhere else. Now I'm going to continue on just to show you that I can get the same result. Okay? Does that make sense to everybody? All right. So I'm going to go, keep on going. Can somebody help me with that again? It was 1, negative 1, 3, 2, 4. 0, 1, negative 2, 1, 0, 0, 1, 2. All right, where do we want to go next if we wanted to do row, reduce row echelon? Where this negative 2 is, I want him to be a 0. How are we going to do that? I'm going to times row 3 by 2 and add that to row 2. Yeah. Yep. So once again, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the process that you will go through to find the specific numbers by using row echelon. Now, if I was only doing row echelon form, I go steps 1 through 6. Everybody there with me and understand what I'm saying by that? Now, this is saying I want this to be a 1, a 0, a 0, a 1, a 0, a 1, a 0, 0. Does that make sense? Well, that's meaning that's in the process to go ahead and go through that. Okay. Yes. You go 1, 2, 3, 4. If I have 4 by 4, which is on your homework, on a 4 by 4, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Going 1 down, next one down, next one down. So the reason why is we need these to be zeros, because when I add up to those, they'll still remain as zeros. Does that make sense? Good with that? Here we go. Let's continue on. So we're going to multiply it by 2, so that's 0, 0, 2, 6. Watch what we get here now. 1, negative 1, 3, 4. 0 plus 0 is 0. 1 plus 0 is 1. Negative 2 plus 2 is 0. 1 plus 6 is 7. Isn't that what we have? Is that why we have? Right? What's the next step? We want to multiply row 3 by what? Negative 3. And add that to row 1. So do that. And then I get 0, 0, negative 3, negative 9. And I add that. 1 plus 0 is 1. Negative 1 plus 0 is negative 1. 3 minus 3 is 0. 4 minus 9 is negative 5. Then I have 0, 1, 0, 7, 0, 0, 1, 3. Now, I don't care where you guys stop. It does not tell you in your homework instructions on what one to do. It's on your own preference. So if you want to stop at row echelon form, great. Does that make sense? If you want to keep going to reduced row echelon form, even better. Okay? Make sense? Everybody good with me on that? Yes, sir. Yes, sir. I'm just showing you that we can continue on to give it exactly all the answers. Okay. Ooh. Oh. No. Okay. What's our last step? Anyone? Add row 2 and row 1 together, right? And I get 1 plus 0 is 1. Negative 1 plus 1, 0. 0 plus 0 is 0. Negative 5 plus 7 is 2. 0, 1, 0, 7. 0, 0, 1. And notice what we have. X is 2. Y is 7. Z is 2. Now you want to know the crappy part about this, guys? This can all be done in 10 seconds. That is true. Well, something the hell messed up. I'm sorry.
No, I'll figure it out.
I can help you. Okay, but I'm going to show you guys something. Now, once again, can you guys use TI graphing calculator? But I just want to show you guys that you're going to be safe. Okay. So, what I have here okay, if you look right here, it's the matrix. And I want to go ahead and do it. And I had this fairly. It's been a while since I've done this. I want to edit a matrix. Notice I have a 3 rows by 4 columns. That's exactly what I have there. So 3 rows, 4 columns. My first one, can you guys go to the very beginning and just read me straight across and straight across. 1, negative 1, 3, 4. Is that what you said? Next one. Okay, see, I'm just plugging it in, right? Okay, go ahead. 5. All right, now watch what I'm going to do. I'm going to quit out, and I'm going to go back in the matrix, where it says math. I'm going to go down. That's row echelon form. That would give us the answer up there. I'm going to do that. So that puts it in not very fun one. But because they decided to divide everything by the 3 there, and you know how we switched the rows, mine just came out pretty good. Does that make sense? Okay, but if I watch this one, if I do it again, matrix, oh, what the hell am I doing? Oh, I'll get alpha. Matrix, math. You see how we reduced row echelon form of matrix A. Try to piss you off a little bit after we do that whole step. Right? But they don't let you use your calculator. No. Because you guys are only allowed to use graph and scientific. So I just wanted to show you because when I like if you ever took the ACT exam, you could solve equations. So, anyway, just yeah, on it every time. For sure. Last 3 times I've done it. It's not like I look at it every time I do it, just so I know what's on the ACT. Has anybody ever seen it on there? Yeah, because you've never seen it, because that's the hard part is, it's really, to be honest, matrices are healthy. They used to be a very distinct way to solve equations, which they are. I mean, this is nice, right? For those people that struggle doing these type of problems, because you're like, I don't really know what's going to eliminate. It gives you a very distinct process of solving. So a lot of people do like it. But it was a way to organize data to go ahead and multiply things. That's really cool. And now with computers and stuff, by doing cells, like in a Excel worksheet or stuff, but still process. I like them just because it's very distinct and orderly. Now, just like last time, did you see times that you have a system of equations that it was infinite solution? Sure, we're going to do one of those just to show you what it is. Okay. My cat, breathe. And I can, all right, here we go. Really good. You guys believe just 2 more tests and you're done with your, some of you guys, your mathematical career? This is the last month. I have to mark you out because it's still school. So if you choose to have your parents, whatever. I have movie school. Really, there's not a lot after the final. I just had to make sure I got the final done before the game day and all that. You can play games. Take one off. It should be there. You should have your calendar. There are 18 tests. I don't know if it is. As I looked at it, I don't think there's roll which one is possible. I don't think that's it. I looked at it, it's statistics is one of them. And that's the afternoon one, and I don't remember the morning one. I looked it up, and it shouldn't have problems. Unless there's like a week here. All right, here we go. Okay, so let's go ahead and do an infinite solution one. Okay, it's the same process that you're going to go through. Really quickly, can we already see who we want to be our top row out of those 3? Can anybody tell me which one of those do I really want to be my top row? The bottom one. Why would you say that? See, there's a 1 already in front of the X. So he's the guy I want there. Does that make sense? I might as well already start there instead of writing all that crap down. Right? Start at the beginning. So I have 1. 1. Negative 10. Negative 6. How do I write this row right here? How do I write this? 8, 7, and 5. And then negative 3, negative 5, 36. Everybody there with me? I understand what you're saying, but the reason why I'm not going to is because as soon as I add these 2 rows together, it's going to be a number. Oh, does that make sense? Because our next goal is I want him to be a 0, isn't it? You okay back to that? Stretch me out. Okay, so what's our first goal that we're going to do? Add row 1 and row 2 together, correct? All right. I'm gonna still keep him. You see where it really was y? One plus zero is one, so there's really negative 10 plus 7 is negative 3, which is negative 1. Once again, I know it takes a lot of paper. They're very tedious work. Yeah. Okay. Whoa. Where? Did I rewrite? Did I write it wrong? Oh, right there. Yep, that's right. I see what you're saying. Thank you. See, that could have thrown us off dramatically, completely, right? So I will say that's one of the rough times. You mess that negative up. Woo! There goes a whirlwind. Okay? And then for you to find it, you're like, screw it, you just throw the whole damn piece of paper away and you go again. Sometimes that's how it goes. You're like, you're giving me a lot of encouragement. Okay, so what we're going to do now, we want to zero where the negative 3 is, right? So I'm going to take row 1, multiply it by row 3, and row 1, multiply it by 3, and add it to row 3. Does everybody understand this notation? We're feeling okay with it? And once again, sometimes if you want to go back and check, you're looking at this notation to make sure you get that notation. Nope. Now, obviously, I can't multiply row, you know what I mean? And that's really why we want him to be a 1 first, so that I can multiply this to make it easy. So now, multiplying him by 3. 3 minus 3, 0. 3 minus 5, negative 2. Negative 30 plus 36 is 6. Negative 12 plus 10 is negative. Any questions on how I got that? Guys, look at that though. Step 4. Yay, it's already done. Right? I'm going to relock into some crap. Okay? You like that. Now step 5, what do we do? We want that negative 2 to be a 3. We want it to be a 0, so I'm going to multiply row 2 by what? By 2 and add it to row 3. Okay. Everybody there with me? Yes, no, maybe. Okay, here we go. So this guy's 2, negative 6, 2. Oh, isn't it? What is 0, 0, 0, 0, 0, 0 mean? Infinite solution, like when 0 equals 0, right? So this is stuff here. This is infinite solution. Now, am I done with just the infinite solution? You want to find that dependent solution. Does that make sense? That's this stuff all over. Okay. So notice what I do is I come back up to row 2. What can we say for row 2? Y minus 3z equals 1. Or we could say y is 3z plus 1. Right? So we there with me? So who is our dependent variable in this case? Y is dependent on z. So our solution so far will be z for our y, be 3z plus 1. Now I need to find x in terms of z, don't I? So then I go back up to the top equation. X plus y, but who is y? So I substitute in for y, 3z plus 1, minus 10z equals negative 2. And then I want to solve for x. Right, Jacob Pipple? I got your damn name now. I don't know why I have a brain for it. And you know, hopefully I know that you know that I know your name. Okay. Does everybody see how x was 7, 0, 5? Okay. And that would be our proof. Now, isn't there 3 other ways I could write this? It is. But if I do it correctly, I should always have this here. So I can solve for z every time. Right? If you're going step by step, you should be able to do it. Okay. Any questions on that? What do you guys think a no solution would look like? You'd have zeros across the bottom, and this would equal like 7, or a number. And that would be a no solution. Do I have to go anywhere further when it's a no solution? Okay. How do we feel? I know we've only done 2. We can do more. I just can't remember what time we did. Want to?
8:52.
The spare of both last pieces. We're doing both of them. I don't know how. All right, should we try one more? Or do yes, sure. All right. Oh, I found that. Okay. So bring me, you get 0, 0, 0, that's infinite. Okay? You understand how this is y minus 3z equals 1. So therefore y is 3z plus 1. So then I came back up here. Here's x plus y, but who is y? 3z plus 1. So I substitute 3z plus 1. And then negative 10. And then I just that help you out? All right. Maybe you're willing to run down to the top of the get your guys' homework stuff while I see the numbers. Ben, can you run down to the top of the really quick? My copy? Thank you. Yeah, you don't go any further. This would just be 0, 0, 0, 1. Or negative 2. You guys want me to show you how to set up a storage problem maybe, Rob? That's where, once again, that is where they're really good at. Is matrices are good to set up a storage problem. Okay, so let's start and do this one. Says a nutritionist is performing an experiment on student volunteers. He wishes to feed his subjects a daily diet consists of 3 combinations of diet food. Mini-cal, liquid fat. That sounds great. And Slim Quick. Okay. For the experiment, it's important that the subject consumes exactly 500 potassium. This potassium, and we want 500 grams. Okay. Protein, he wants exactly 75 grams. And then vitamin D, he wants 1,150 units. But the potassium in mini-cal is 50. For liquid fat, it's 75. For Slim Quick, it's 10. For protein, for mini-fat, for mini-cal is 5. 10. 3. Vitamin D, we have 90, 100, and 50. You guys see our equation come up here? Here we go. 50 times x, 75 times L or Y, 10 times V equals 500. You see how it's very organized to set it up? So you'd have 50 plus 50x plus 75, y plus 10z equals 500. Then I'd have 5x plus 10y plus 3z equals 75. 90x plus 100y plus 50z equals 1100. So it's just already set. Which ones we pass in? That's why you label it. So it really doesn't matter, because what does X represent? The goal is to be wondering how much of each of these things is each person. Okay? All right. Now, just be aware, I know, once again, the end of the year is coming. It's hard to sometimes come every day, but I'm telling you, in the last half, the people that were here early, you did a lot better, right? People that struggle, have a good time. So please make sure you're here. It really does help out. I know it's getting hard at the end of the year. I've been there. I've done that, right? Just push till May 15th, and then after that, you can say, screw you, man. I don't have to see you again. Right? Unless you're getting continue on. But continue to push. This is your packet for the rest of, just the rest of chapter 10. We will have one more unit of chapter 12. Let's see what we're going to do here. Five through 59, every other odd. Once again, that's just a minimum standard, right? If you need to do more to practice more, that is on you. Please, I'm just making sure you have enough to get you through it. Right? Okay. Yeah. Okay, guys, have a good day. Thank you, I appreciate you. You go to